This is lesson 3.6, and we're going to talk about some compound inequalities. I'd like you to take some notes, so have your notebook out and set them up for Cornell Notes. If you need to hit the pause button so you can get this set up, go ahead and do that, and when you're ready, hit play. Alright, today's lesson is about solving inequalities that use the words and or. And in the English language, and or are called conjunctions. And conjunctions just combine sentences to make a compound sentence. If I said I went out to dinner, and that's one sentence. And then if I said I went to the movies, that would be another sentence. I could use the word and or to combine those two sentences together. I went to the movies and I went out to dinner. Or you could say I went to the movies or I went out to dinner. The same is true in math with compound inequalities. You're going to use the words and or. And just so you're getting in the right frame of mind, the word and means both. I can have a Snickers and I can have a Milky Way. That's both. Both a Snickers and a Milky Way. But if I say or, I can have a Snickers or a Milky Way. It's either one or the other. So in math, when you have a compound inequality that uses the word and, it's going to look something like this. Let's say I have x is greater than or equal to 3. That's a graph that looks like this. All the numbers, including 3 and greater. And let's say I have another graph that says x is less than or equal to 7. It's a graph that looks like this. I can take and use the word and to join these two inequalities together and say I want to know all the numbers x greater than 3 and x less than or equal to 7. Well, it would look like this. All these numbers and all these numbers combined. And the result would be an inequality that looks like this. It's in green. It would be all the numbers greater than or equal to 3 and less than or equal to 7. All right. If I use the word or to combine inequalities, it will look something like this. Now, this is sort of an overview, so if you're a little bit confused by what I'm showing you, just stay with me and I'll show you some examples and it will become clearer. So if I have the inequality x is less than negative 2, the graph of that looks like this. And if I have another inequality that says x is greater than or equal to 1, the graph of that looks like this. And if I join them together with the word or, and say x is less than negative 2 or x is greater than or equal to 1, it would look like this. So the graph of the inequality combined by the word or looks like this, where the arrows point in opposite directions. So when you have an inequality that's joined by an and, I like to think of it like my two fists together with my thumbs touching. That's an and. It kind of looks like a dumbbell. That's an and compound inequality. And when you have a compound inequality with the or, that's where my thumbs are pointing out. So I like to think of it like this. If I put my hands together and hand, put my hands together, or my thumbs go out the door, or out the door, and hand. So let's look at some examples. So if you're taking notes, which you should be, you can write down problem 1, and then A. And A says all real numbers that are greater than negative 2 and less than 6. So this is an and inequality, compound inequality, and I'm going to write it like this. All real numbers that are greater than negative 2 can be written like x is greater than negative 2. And numbers that are less than 6 would be x is less than 6. That's an and compound inequality, and you can graph that inequality like this. First, make a number line. The two numbers that are involved in this inequality are negative 2 and 6. So I'm going to make a number line that goes from -2 to 6. What I'm not going to do is just throw -2 and 6 on there and call it good. You have to actually use a scale and write numbers on it. So I'm going to start with -2, but because I'm going all the way up to 6, I'm going to go by 2's. So 2 up from -2 would be 0, and 2 more would be 2, and 2 more would be 4, 2 more, 6. There's a number line, has a proper scale on it. Now I'm going to graph it. X is greater than -2 because it's strictly greater than. It's an open circle at -2, and the arrow points to the right. Now I graph X is less than 6, starting at 6, open circle because it's strictly less than, arrow to the left. Well, the numbers that intersect this inequality and this inequality are just the numbers in the middle. So your graph for X is greater than -2 and less than 6 would just be the section in the middle. And that's a graph of an and. It looks like the two hands with the thumbs together, or it looks like a dumbbell. Terrible drawing of hands. All right, part B. B says all real numbers that are less than 0 or greater than or equal to 5. This is an or compound inequality. And I'm going to write it out like this. All real numbers that are less than 0 is X less than 0, or greater than or equal to 5 is X is greater than or equal to 5. That's an or. And again, I'm going to graph this one. The two numbers that are involved in these two inequalities are 0 and 5. So I'm going to put 0 and 5 on my number line, but I'm going to use a real scale. 0, 1, 2, 3, 4, 5. The graph of X is less than 0 is a circle at 0, and it's open because it's strictly less than. And less than means to the left. X is greater than or equal to 5. Circle at 5. This time it's filled in because it's also equal to. And then it's an arrow to the right. This is an or statement. This is where your thumbs are pointing out or out the door. Now, if you go back to example A, this graph of X is greater than -2 and X is less than 6, what you have is a description of all the numbers that are between -2 and 6. So another way to say an and compound inequality is to call it a between, because it's really describing numbers that are between two numbers. And because this is a between compound inequality, another way to write it, other than what I have up here, is to actually physically put the letter X between -2 and +6. But you can't just write it like that. You have to put some inequalities in there. So you can say that X is greater than -2, just like you did up here. And you can say X is less than 6, just like you did right here. So a special way to write the and compound inequalities is to call it a between statement and to write it like this. Now, take a look at problem 2. Write down problem 2 on your paper, and you can copy the problem, which I will do for you. That'll give you more time to copy it down in your notes. This is a compound inequality. Now, just by looking at it, you can tell that this compound inequality is an and compound inequality because it's written in that special way that I just described. You can also notice that it says and right here. That's why it's an and. But in this inequality, it's not simplified or solved. So your first step is to solve this compound inequality. So if you look in the middle where the variable is, it says 3y minus 4. if I gave you an equation that said 3y minus 4 equals 10, your first step would be add 4 to get rid of the minus 4. And what you do on one side of an equation, you do on the other side. Well, a compound inequality is very similar. The first step I'm going to do is to add 4 to get rid of this minus 4. But because it's a compound inequality, what I do on one side of the inequality, I have to do on the other side and the other side. So if you do it one place in the inequality, you do it everywhere. So I'm going to add 4 here, and I'm going to add 4 here. Negative 2 plus 4 is 2. What's left in the middle is 3y, and 14 plus 4 is 18. And now the last step to simplify or solve this inequality is to divide by 3. And if I do that here, I have to do it here, and I have to do it here. So my answer is y is between 2/3 and 18 divided by 3 is 6. Or I could say y is greater than 2/3 and y is less than 6. Again, you're going to graph these. And you're not going to just throw 2/3 on a graph and 6 on a graph. In fact, we're not even going to put 2/3 on the number line. We're going to go from 0, 1, 2, 3, 4, 5, 6. Notice that I only wrote every other number, just the even ones. It's not necessary to write every number, but it is necessary to have a consistent scale. 2/3 is between 0 and 1, so it's about right here. And it's a circle here because it's less than, not equal to, it's open. 6 because it's less than and not equal to, it's open. And all the numbers between 2/3 and 6, the graph looks like a dumbbell, just like that. Okay, last example. This is an example of an OR compound inequality, and you know it's an OR compound inequality because there's the word OR in it. And it says 3t plus 2 is less than negative 7, or negative 4t plus 5 is less than 1. With an OR compound inequality, you're basically just solving two separate inequalities and then putting them on one graph. So on the left-hand side, we're going to solve 3t plus 2 is less than negative 7. First step is to subtract 2. When I do that, the 2's go away. I'm left with 3t is less than negative 7, and negative 2 is negative 9. Divide both sides by 3. And you get t is less than negative 3. Or solve the other one. Subtract 5 from both sides. 1 minus 5 is negative 4. Now to finish this one, I'm going to divide both sides by negative 4, and at the same time, I'm going to remember that when I divide by a negative number, I have to flip the inequality. Negative 4 divided by negative 4 is 1. So this compound inequality using OR says t is less than negative 3, or t is greater than 1. So I graph it. The two numbers involved in this inequality are negative 3 and 1. So I'm going to start at negative 3, negative 2, negative 1, 0, 1. T is less than negative 3 is an open circle at negative 3 and an arrow to the left. That's all the numbers less than negative 3. T greater than 1 is an open circle at 1. All the numbers to the right. Those are all the numbers greater than 1. And that's it. That's an OR out the door. That's pretty much all of lesson 3.6, at least for part 1. Part 2 will be a different video.